So here we have the RCA CR-91A receiver, and this time I thought I'd check the IF response curves on an Agilent test set. I don't normally use this IF response curves. It's a great machine, but it's kind of noisy. You can probably hear the noise in the background, and it really gets on my nerves. And I'm really thinking of buying a better spectrum analyzer, a more modern one than this. But this set has got quite a few useful features besides the spectrum analyzer in it. Anyway, at the moment we've got the set on the broadest selectivity position. And you can see here it's quite a broad curve, not quite a flat top. It's probably about as good as you're going to get on a set like this. Can't get it exactly flat, but that's good for general kind of I guess broadcast band listening. But this set hasn't got broadcast band on it, so I don't know what you'd use this setting for. Anyway, we'll go to the next position, which would be the normal position for a sort of an AM signal. And you can see now the response is changing. I've got this on a 5 times smoothing to smooth the curve out a little bit. So the center frequency is set at the crystal center frequency. It's 734.78 kilohertz, and that's where the marker is on the curve there. So it's exactly right in the center. Nice sort of symmetrical curve, and this is the normal sort of AM receiving selectivity you'd use. I'll switch on to the first of the crystal positions, which is 3. Hear the different tone there as it sweeps through the crystal, and you can now see the typical crystal response curve, which if I tweak the phasing control, you can see it alters the shape of that curve. You can see the dip on the sort of on the low frequency side of the curve, and the peak more or less at the crystal resonant frequency changing. So you can adjust this to suit the reception conditions. Switch to the next steepest response curve, and again I can change the response with the crystal phasing control. Get much more of a steep peak if I just want a peak of the curve there, which is great for CW reception in noisy conditions where you've got a Json channel interference. You can get rid of that. But the spectrum analyzer resolution bandwidth, it sets it automatically depending on the sweep width. I've got it set at 60 kilohertz width at the moment, and at 1 kilohertz at this crystal setting, it is not really getting the resolution on the response curve. So I'll try changing the span to something like, say, 25 kilohertz. See we're now down to 300 hertz resolution bandwidth. You can see the response is quite different because you've got the much narrower span now of 25 kilohertz. Again, I can change that curve quite a bit with the crystal phasing control. But again, 300 hertz is not really capturing the extreme peak of this curve. We're managing to get the null a little bit better, but the peak isn't there. It's missing it because the peak is so narrow. And on the steepest crystal frequency, steepest selectivity position, again, its resolution bandwidth of 300 hertz just isn't there for to capture the peak of this curve, and that's why I prefer to use the this analog setup here. It's kind of old, creaky, but the old HP 8601A, and it's matching 8600A marker generator, and using it with a tech monitor. That actually will capture those curves. It's an analog setup. It will capture the peak of those crystal response curves, whereas at least this spectrum analyzer doesn't do that. It does a reasonable job, but it doesn't quite get there. So anyway, as I say, I'm thinking of investing in a better spectrum analyzer. There we go. Just thought I'd do a little extra demo there. This receiver's ready for its owner to collect now. I think it's about as good I'm going to get on the selectivity settings by adjusting the IF transformers and the crystal trimmers. And the RF section tuned up really well. It's actually very, very good receiver.